13.2, sine and cosine ratios, geometry. Essential question, how can you use the sine and cosine ratios and their inverses in calculations involving right triangles? So here you are having triangle ABC, it's a right triangle, guts 90 degrees. Instead of using tangent like we did before, now we're going to use cosine and sine. So sine is opposite over hypotenuse, unlike tangent. So basically the sine of angle A equals the opposite, which is BC, over or divided by the hypotenuse, which is just AB. And that is the sine ratio for angle A. Cosine, on the other hand, I'll use a different color. The cosine of angle A, unlike sine, instead of opposite over hypotenuse, will be adjacent over hypotenuse. So its ratio is going to be AC all over AB. So that's what sine and cosine looks like as opposed to tangent. Notice how we're using the hypotenuse for both of them. So your answer to your essential question is, given the measure of one acute angle and the length of the hypotenuse, you can use sine and cosine ratios to find the lengths of each leg. Then use the inverses to find the measure of each acute angle. So again, both are relying on the hypotenuse. Once again, if you know SOHCAHTOA, you know basically 80% of all trig. So sine is opposite over hypotenuse. Cosine is going to be adjacent over the hypotenuse. And tangent is going to be the opposite over the adjacent, just like in 13.1. So again, if you know SOHCAHTOA, he's a great Indian chieftain. He'll basically remind you of 80% of everything involving trig. So examples 1 through 4. Sine of angle D. So we go to angle D. Sine is opposite over the hypotenuse. So opposite over the hypotenuse. This is how I used to write when I was a kid, when I was your age. So I get 8 over 17. Now for cosine of angle D, remember cosine is adjacent over hypotenuse. So the adjacent will be 15, and my hypotenuse will be 17. Both sine and cosine are relying on your hypotenuse. So you have 15 over 17. So if you want practice, you can try sine F and cosine F. I'm going to do them right now. Okay, so if I go to sine F, I go to my angle. So sine again is opposite over hypotenuse. So notice it really depends on what angle you're staring from. Okay, so sine of F is 15 over 17. Which is interesting because didn't we get that for cosine of angle D? And we're going to talk about complementary angles because of this situation. So let's go ahead and use cosine of F, and let's find him. Cosine of F, I'll do in red. Adjacent. His adjacent is 8. Adjacent, again, just means right across from him, like right next to him. Okay, over hypotenuse. 8 over 17. Okay, and if you notice, there's a connection here as well, and that's because of complementary angles. Okay, if you add them both together, you should get 90 degrees. And that's the reason why we get that pattern. All right, trigonometric ratios of complementary angles. So make sure you write all this down. Basically, it's just saying if you know one of your acute angles, basically like if you know angle A, for example, you can actually find the ratio for angle B. And you're using this. So if you use the sine of whatever angle A is, you set it equal to the cosine of 90 minus whatever that angle was. So let's use it in application. So example 5 through 6, we have the sine of 38 degrees equaling this ratio. So use your complementary angles from your last slide. Sine of 38 degrees equals cosine of 90 minus 38. Because again, complementary angles both add up to 90 degrees, so we know that the missing piece has to be the difference between 90 and 38. And you should get 52. So your complementary angle is 52 degrees, and cosine of 52 degrees is actually going to equal the same approximation that sine of 38 degrees is, which is a great way to double check your work, and it's also one of your questions that you'll see on your test. So be sure how to know this, okay? If these two numbers don't match, you're doing it wrong, okay? So double check. All right, last example for this situation. You have cosine of 60 degrees equaling 0.5. So we're going to set up our complementary angle, which will be sine of 90 degrees. Again, we're going to find the difference. 90 minus 60. You do that in your head, you just get 30. So sine of 30 degrees. And fun fact, if you do it correctly, you should equal 0.5, the same ratio that was given to you in your complementary. On your test, they're going to ask you to write something like this, and then to get the ratio over here. Okay, so like I think the first point will be there, and your second point for your answer will be here. Okay. Finding the side lengths using sine and cosine. So we're not just learning this because we want to torture you guys. We're learning this because construction uses it, astronomers use it, even ancients have used it. So let's say we want to find x and y, okay, of a ramp. We have an angle given to us, an acute angle, so acute, all right? And basically you're going to look at, well, we have sine and cosine. So if we look at sine of angle A, x is his opposite, and his hypotenuse is 12. So we can find the height of the wall by using sine. So sine of 11 degrees equals the opposite over the hypotenuse. Go ahead and multiply to get rid of that dividing 12 on the right-hand side. Okay, so x equals 12 times sine of 11 degrees. So in your calculator, make sure you type in 11, press sine. You're going to get some really crazy number. Multiply it times 12, and you should get x equals 2.28, and they want us to round to the nearest foot, or to the 10th, okay? So I'll round up, so x equals 2.3 feet. That's how we're going to find the height of San Gorgonio and Blue Mountain, okay? Same process. Now, to find the floor, y, okay, we're going to have to use cosine because y is the adjacent of A, and we can still use the hypotenuse, okay? So we're going to use cosine. Cosine of 11 degrees equals adjacent, y, over the hypotenuse. Same process as the one with the sine, just multiply both the left hand and right hand side by 12, and y is going to equal 12 times cosine of 11. So in your calculator, press 11, press cosine. You're going to get a really crazy number, times 12, and you should get y is approximately 11.779. Go ahead and round to the 10th, so 11.8 feet. That's very useful, especially when you can't walk out into space for a couple million of miles or a million light years. You really can't do that. So using this equation, it's a lot easier than just trying to fly out there. All right, inverses of sine and cosine. So here we have two sides, but we didn't get an acute angle. So we're going to find angles. So let's go ahead and start with angle R. If you notice from angle R, his opposite is 7, and his hypotenuse is 13. So if I wanted to find angle R, I would say sine R equals the opposite over the hypotenuse. And this is where the inverse of sine, just like how the inverse of tangent works. You go ahead and do the inverse of sine. Okay, to both the left hand and right hand side. You're going to get angle R equals, and this is how you use it in your calculator. You're going to take 7 divided by 13. And then if you look at your calculator, you'll see sine. Press second first, and then sine. And you'll use the inverse. So angle R is given to me as 32.57. You could round up if you want to 32.6, and you'll be fine, okay? But that's how you could find angles. You could do the same thing with cosine if you really wanted to. For example, if you look at angle P, okay, you can have also done this. The adjacent divided by the hypotenuse. So cosine of P equals 7 over 13. If you really want just a quick way of doing this, you literally just type in 7 over 13 and then inverse of cosine, and you get your answer within about 5 seconds. It's kind of nice. So 7 divided by 13, and then inverse of cosine. Make sure you press the right buttons. Some people go a little too fast. So angle P is approximately 57.4 degrees, which makes sense because complementary angles, remember? Angle P plus angle R should get you 90 degrees when you add them together. If they don't add up anywhere near to 90 degrees, you're off. Something's off, okay? Great way to double check yourself. Here's your homework, page 703 through 704, numbers 1 through 16. If you have any questions, please let me know. Good luck.